Okay, we are looking at Unit 4, Lesson 9. When are they the same? Let's use equations to think about situations. So now we're taking a look at some other situations and some real life situations and how equations fit in with real life. So the first thing we're going to do is look at a babysitting scenario. You have two options on how you would charge somebody to babysit for them. So would you rather charge $5 for the first hour and $8 for each additional hour? Or would you rather charge $15 for the first hour and $6 for each additional hour? So take a minute, hit pause, decide which of those babysitting payment plans sound better to you. Which would you pick? Okay, so maybe you decided, make yourself a little note. Maybe you had to jot down some math or whatever. But think about, which did you prefer? Now, I do have a question. Is there a chance that they both could be good options depending on how much time you have to babysit for? So take a minute and decide, how much would you make? Oops. How much would you make if, let me make my pen a little bigger here. How much would you make if it was for 2 hours? So take a minute for each and decide, how much would it cost to babysit for 2 hours for each of these options. So pause the video and figure that out. Now, how about for 5 hours? How much would you make if you babysat for 5 hours? How about 10 hours? That's a long time to babysit, but who knows? All right, so is what you chose originally still your best option? Because there will be a point where one option actually becomes the better option. So this is kind of like what we're looking at today, where we have some scenarios and there will be a point where one scenario might be a better option than the other, or where something is happening and then at a certain point in time things switch around. And this is a good way to kind of think about that. Now, on a side note, as you were doing your work, keeping in mind that when we look at these scenarios, you want to pay close attention to the instructions, because, for example, for 2 hours, the $5 is for the first hour and then 8 for each additional. So for the 2 hours, it's 5 for the first hour plus 8 for that second hour, right? For 5 hours, it would be 5 for that first hour. So that's hour 1. So then for the 4 hours, it would be $8 for 4 hours is 32. Right? So as you were doing your math, make sure that you're looking at the instructions or at the pay scale correctly. So take a minute, see if you can kind of still decide which is the better option. So our next situation here, 9.2, we have water tanks. It says the amount of water in 2 tanks every 5 minutes is shown in the table. So each of my rows shows a 5-minute change. So 5 minutes, right? So from time 0, this is our start, to 5 minutes, tank 1 increased by 150. And in the next 5 minutes, tank 1 increased by 150. Okay, so even though water doesn't really fill or drain at a perfect speed, for this scenario, we're imagining that it's changing at a consistent speed. Now for tank 2, every 5 minutes, it's decreasing by 100. Okay, so take a minute and just look at the behavior of these two tanks. What's happening during the time period that we have here? And everything is staying consistent. This isn't a table where all of a sudden things are going to change or get strange. Okay, so number 1 says, describe what is happening in each tank. Either draw a picture, say it verbally, write a few sentences. You decide how you want to describe what's happening. When we looked at the table here, if it was me, I would say that tank 1 increases 150 liters every 5 minutes. And tank 2 decreases 100 every 5 minutes. You can draw a picture if you'd like. You can, you kind of decide how you want to describe what's happening. Number 2, use the table to estimate when the tanks will have the same amount of water. So take a minute and compare tank 1 and 2 and see if you can figure out, we don't need an exact number, we just want an estimate. So can you estimate around when are they going to have the same amount of water? So push pause and take a second, and I want to see if you can figure out about when that's going to happen. All right. So when I look at this, I'm going to compare the two tanks numbers. So if we look at our first row here, 25 and 1,000, then we have 175, 900, 325, 800. So I'm just going to go through and compare my two numbers, 475, 700, 625, 600, 775, 500. Now, if you look around this area here, there's a shift that happens, right? I went on tank 1, I went from 475 to 625 to 775. In tank 2, I went from 700 to 600 to 500. So this is kind of like where the tanks shift in what they have inside their liters, right? So if it was me, I would look here and I would say, well, at some point between 15 and 20 minutes, they have the same amount of water, right? Because in tank 1, 475 becomes 625. And in tank 2, 600 or 700 becomes 600. So at some point in here, they will have the same amount of water. So somewhere between 15 and 20 minutes, they should have the same amount of water. We don't have to know exactly when yet, but we will find out. Okay. Number 3. The amount of water in liters in tank 1 after T minutes is 30 30T plus 25. The amount of water in liters in tank 2 after T minutes is negative 20T plus 1000. Find the time when the amount of water will be equal. Okay, so a couple things happening here. It says the amount of water in liters in tank 1 after T minutes. I want to talk about the T for a second. So remember, when we don't know an amount or a number, we use a variable, right? And they're telling us we're going to call the minutes T. The only thing is on the chart, we actually have minutes, right? So it might be a little confusing that, well, if we have the minutes, why are we needing a T? Well, if we think about the question, we actually have a specific time we're trying to find. Find the time when the amount of water will be equal. So now the time we're given are 5-minute increments. And we know that the time that the water is equal between 15 and 20 minutes, but we need to find the actual time. So that's why we're looking for T, because we want an actual time that they have the same amount of water. Okay, so now let's take a look at the equations that they came up with. So for our tank number 1, the equation they give is 30T plus 25. I'm going to write that under tank 1 just so that we can kind of see what's happening in these equations. Now tank 2 is negative 20T plus 1000. So let's take a minute and let's see kind of where they may have pulled these numbers from. So if we look at tank 1, we'll get to the 30 in a second, but let's look at the 25. Look at tank 1 and see if you can locate 25. 25 is the first value in our list. At 0 minutes, tank 1 has 25 liters. This is where we start. So we start at 25. It's our beginning amount. If we look at tank 2, find 1000. That's where tank 2's levels begin. So this number at the end is where we begin in our measurements. Okay, so now let's look at the 30 and the negative 20. Now we know T is time in minutes. T is time in minutes, but it's 1 minute. So T only represents, in the situation when we're talking about what the T is each minute that we're looking at. So if we had 4 minutes, T would be 4. If we had 3 minutes, T would be 3. Okay, so when we look at 30T, let's see if we can figure out how that number came about. Because if we look at our chart, we're increasing by 150 liters. How would they get 30 from the 150? The 150 is over how much time? The 150 is in 5 minutes. So if we have, I'm going to write off to the side here. So this increases 150 liters in 5 minutes. How many liters would that be in 1 minute? So how many liters would that be in 1 minute? Be 30 liters. This is actually the unit rate. 30 liters in 1 minute. So if we look at tank 2, negative 20. Let's see if the same thing is holding true there. So it decreases 100 liters in 5 minutes. So how many liters in 1 minute does it decrease? It decreases 20 liters in 1 minute. It's our rate. So that's where they get the numbers for these equations. All right. So now let's actually look at what they're asking us to do. So they're asking us to find the time when the amount of water will be equal. So I want to know when the amount of water in tank A is equal to the amount of water in tank B. So we're just going to solve the equation. So I'm going to set up the expression for tank 1 and make it equal to the expression in tank 2. Because it literally says, when are they going to be equal? So take the equations you're given or the expressions and make them equal. Uh-oh. I don't know what just happened. So we're going to start solving. I'm going to add 20t to both sides. I'm left with 1,000 on the right. Subtract 25 from both sides. I'm going to have to move up here. Sorry, you should have more room on yours than I do. 50t equals 975. Divide each side by 50. And I get t equals 19.5. So again, hopefully you have more room than I have here. So t equals 19.5. So that means that after 19.5 seconds, my water will be equal or the same level. So water will be equal after 19.5 minutes. Did I say seconds? I meant minutes. So water will be equal, or it'll be the same depth, same amount of liters after 19.5 minutes. And again, hopefully you should have enough room on your paper. Okay, let's look at the next one. Okay, 9.3 elevators. A building has 2 elevators that both go above and below ground. At a certain time of day, the travel time it takes elevator A to reach height h in meters is 0.8 h plus 16 seconds. So this is the expression that represents the amount of time it takes elevator A to reach height h. So for elevator B, the travel time it takes for elevator B to reach height h is negative 0.8 h plus 12. Okay, so there's a specific time of day where if you looked at this expression, it could tell you where the elevator is at. Okay, so we want to remember that the height is h. Now, travel time is another piece of information that's going to be important to us in just a minute too. So travel time for elevator B to reach height h. We're going to come back to look at those a little bit more in just a second. So now question number 1 here says, what is the height of each elevator at this time? So the picture says, what's the height of each elevator at this time? So when they say this time, we mean like right now. Right now, the beginning of our problem, according to the picture, where are the elevators? Okay, now the thing is at this time, what time? Okay, so let's think about what time we're talking about. Well, we're just starting this problem. I don't know what time of day it is, but we can look at this as in like the start. Okay, so when we start our calculations or we start measuring, our start time would be 0. Okay, so our start time is going to be 0. Okay, so that's our beginning. Now here's the thing, where does the time fit in here? Okay, it says at a certain time of day, the travel time it takes the elevator. So our time to reach the height is. So whenever we see is, we know there's an equal sign. So the time is equal to 0.8h plus 16. Same thing goes for elevator B. The time it takes to reach height h is negative 0.8h plus 12. The other thing to think about, it's 12 seconds, right? So if I knew the h or the height and I plugged it in, the number I would get would actually be read in seconds. So that's another cue that we're dealing with time equals. Okay, so keep that in mind that just by looking at my sentence, time is, and then they give us our expression. Okay, so when our question number 1 says, what's the height of each elevator at this time? We're going to call time 0 because 0 is when we're starting. So instead of the word time, I'm going to put a 0. So for elevator A, I'm going to set the time as 0. So 0.8h plus 16 equals 0. So what this is going to do is this is going to tell me when I figure out h is the height when the time is 0. For elevator B, I'm going to do the same type of thing. I'm going to take the equation and make it equal 0 because my time at the beginning is 0. No seconds have passed. So at no seconds, where are my elevators? So we're just going to solve. Don't let the 0 over there make you nervous. We're just going to do our math. So I subtract 16 from each side. And then now I'm going to divide by 0.8. And that gives me a height of negative 20. So the height is negative 20. Oops. So the height is negative 20 at the beginning of this experiment. Now let's look at elevator B. I'm going to solve. My 12s cancel. Now divide by negative 0.8. And when I divide, my height equals 15. So what's happening here is that for elevator A, the height is negative 20 meters at time equals 0, right? And elevator B, height is 15 meters at time equals 0. So at the beginning, as we're starting our problem, the height of elevator A is -20. The height of elevator B is 15. So take a second and see if you can figure out which of these elevators is A and which is B. Okay. So hopefully you saw that elevator A is at -20 meters. Now, this is ground level. So anything below ground level is a negative. So A would be the elevator on the right because it's 20 below. Elevator B is on the left because it's at 15. Now remember that was just at the start, right? Let's look at number 2. How long would it take each elevator to reach ground level at this time? So how long will it take each to hit ground level? Now, because we're saying how long, that means we need to find t, right? Find the time. So that's what I'm looking for. That's what I don't know. Now it says to reach ground level. What would the height of ground level be? What do you think we could call the height of like the main floor? Well, the height would equal 0. Zero is our main ground level, right? Just like if you were looking at sea level or a temperature gauge, right? At sea level or a temperature, this middle ground here is 0. So we need to find the time when the height is 0. Okay, so for elevator A, so let's look at elevator A. What's the time when the height is 0? So I'm going to go back to my original equation setup, and I'm going to say, okay, well, if I need to find the time when h is 0, right? So if h is 0, 0.8 times 0 cancels out, and I'm left with 16. So the height is 0 at 16 seconds. It's as easy as that. So for elevator B, let's do the same thing. What's the time going to be when the height is 0 feet, or meters, excuse me. So when the height is 0, now we're replacing the h. Negative 0.8 times 0 is just 0. And I get t equals 12. So the height is 0 at 12 seconds. So at this specific time of day, it takes 16 seconds for elevator A to get to ground level. At this certain time of day, it takes elevator B 12 seconds to get to ground level. So we've got two elevators that are not moving at the same speed or getting places at the same time, right? Okay, now your paper will you can still see your picture on your paper, not on my screen. But let's take a look at numbers 3 and 4. 3 says, if the two elevators travel toward one another, at what height do they pass each other? how long would it take? So if the two elevators are traveling toward each other, at what height do they pass? So by them saying at what height do they pass each other, that's basically asking, when will the height be equal? Says how long would it take? So we are looking for time, right? Or so how long would it take for the height to be equal? And then we're going to figure out the time. So for me to figure out when the height will be equal, I need to figure out when these two elevator equations will be equal. So I need to know when elevator A is going to equal elevator B. So let's take our expression for elevator A. And make it equal to the expression for elevator B. And then we're going to solve it. So I'm going to add 0.8 to each side, 0.8h. Because now we remember when we solve, we want to get the variables together on one side, numbers on the other. And this is not a special situation because I've got different coefficients. My number in front of the h is different. So I get 1.6h plus 16 equals 12. Subtract 16 on each side. And we get 1.6h equals negative 4. Divide each side by 1.6. And h equals negative 2.5. So this is telling me that they will pass at 2.5 meters below ground level. Now it asks us how long will it take? That's a time, right? So what we can do is we can take one of our elevators, because remember now at negative 2.5, that means that the elevators pass each other at that point. So what we can do is I know that time equals, we're just going to pick elevator A. 0.8. Now my height's going to be negative 2.5. Because remember, how long will it take for this specific situation, right? So in this situation, the height is negative 2.5. So if I plug the height into one of my elevator situation equations, let's see what happens. So if I multiply 0.8 times negative 2.5, I get negative 2 plus 16 is positive 14. So this is saying it's going to take 14 seconds. So after 14 seconds, the elevators will pass each other. Okay, number 4. If you are on an underground parking level 14 meters below ground, which elevator would reach you first? Okay, so let's say you are on level 14. You want to figure out which elevator is getting to you first. Now, 14 meters below ground. So this would be our height, right? So which would reach you first? So that means which is fastest? And which is fastest would mean which is going to take the least amount of time, right? So we need to find some time when the height is 14 meters. So T is what we're looking for. So let's look at elevator A. I want to know what's the time going to be when my height is 14 meters. So we're going to go back to that original equation. We need the time because that's going to tell us which was fastest. The height is 14 meters, right? Now, hopefully you thought about this, but we're 14 meters below ground. So make sure that you're using negative 14. All right, so when we do some calculating here, we get negative 11.2 plus 16. Sorry, it's positive 4.8 seconds. Elevator B. Time is going to be negative 0.8 at negative 14 feet plus 12. So now I get positive 11.2 plus 12. So for elevator B, the time is going to be 23.2 seconds. So this is saying that it takes 4.8 seconds to get to negative 14 meters. Right? And elevator B takes 23.2 seconds to get to negative 14 meters. So which was faster? A. Elevator A only took 4.8 seconds to get to me 14 meters below ground. And that's it.